All the real zeros of a given polynomial are integers. Find the zeros and write the polynomial in factored form. So using the rational root theorem, I know that my roots, my rational roots, will be the factors of this divided by the leading coefficient, which is 1. So it's going to be plus or minus the factors of 4, which is going to be 4, 2, or 1, divided by the factors of 1, which is just 1. So what my integers could be are 4 plus or minus 4 plus or minus 2 plus or minus 1. Now, if I had more than one factor down here, then I would have to make sure I do all of those over. So if there was like a 2 here, I'd have to do 4 halves and 2 halves and 2 over 1 and all that stuff. But this is a 1, so it's just these. Those are my only options. So let's try 4 first. So I can do 4, and I do synthetic division. 1, negative 2, negative 3, 8, negative 4. Well, this comes down to become a 1. 1 times 4 is 4. Negative 2 plus 4 is 2. This is 8, 5. 4 times 5 is 20. That's going to be 28. 4 times 28 is 112. And that gives me 108. And if you notice right here, that is not 0, which means 4 does not work. Also, if you remember in class, if you notice, this never changes sign. Every single one of these guys are positive, which means that this right here is too big. So I don't want to pick anything that is bigger than 4 because it would be too big. Now, 4 was our biggest number, so we don't have a problem with that, but I wanted to show you what that would look like. Now let's try another one. Let's try negative 4. 1, negative 2, negative 3, 8, negative 4. So we drop this one, that's 1. Negative 4, negative 6. Negative 4 times negative 6 is 24. That's going to be 21. 21 times negative 4 is negative 84. Negative 76. Negative 76 times 4 is 304. That's 300. Okay, that is not 0. And if you notice here, these change signs every time. And if they change signs every time, that means this is too small. I want to pick something bigger. But once again, it's the smallest one we had. But if it wasn't, I would just make sure I don't choose anything smaller than that. Let's try one more. Let's try negative 2. 1, negative 2, negative 3, 8, negative 4. So this drops down. 1, negative 2, negative 4, positive 8. That's going to be 5. That's negative 10. That's going to be negative 2. Negative 2 times 2 is 4. We got a 0. So if it's 0, that means that that is a root. And this actually, right here, this factors out to be x plus 2. Because if you remember, this is the root of this. And then it factors out to be the rest of this with 1 degree less. So x cubed minus 4x squared plus 5x minus 2. So that's what that factors out to be. Now what we need to do is we need to factor this even more. So I'm going to pull this up. And now the rational root theorem, look at this. It's going to be the factors of 2 over the factors of 1, which means that if I would have picked negative 2 from the very beginning, I would have found out very quickly that 4 was not going to be one of them. So let's do another one. So I'm going to now use this, negative 4, 5, negative 2. I no longer have to use this to divide from. I can now use this. And I'm going to choose, let's go 2 this time. Now, negative 2 could happen again, so don't think that it's not going to, but I'm going to choose 2 for right now. So that's 1, 2, negative 2, negative 4, 1, 2, 0. So I found another root. So what I'm going to do is I'm going to leave this here. So I end up getting x plus 2. And then I'm going to factor this out to be the factor here and that right there. So that's going to be x minus 2, mainly because this is the root of this again. And then the next piece is going to come from this. So that's going to be 1 degree less than x cubed. So that's x squared minus 2x plus 1. So I'm going to move this up here. Now, if you notice right here, the factors of 1 over the factors of 1 is only plus or minus 1, which means 2 is no longer an option. And I could just keep going with all of this, or if you notice, this is quadratic, which means now I can just factor it. So this becomes x plus 2, x minus 2, and this will factor out x. Two things that multiply to 1 but give me negative 2 is going to be negative 1 and negative 1. So p of x factors out to be x plus 2, x minus 2, and then x minus 1 squared, which means that my zeros, or my roots, are going to be negative 2, 2, and 1. And if you remember, 1 has a multiplicity of 2, but it just asks for the zeros. So there are my zeros, and this is it factored.